Alright, let's look at an example where the water level in a reservoir is modeled using a linear function. So this says f of t is the function which measures the level of water in a reservoir at any time t. And this f of t is given by 4.5 times t plus 28. So let's see what this really means. First of all, when t is 0, this is 4.5 times 0 plus 28 means it is 28. So there's some reservoir initially at t equals 0. Let's say the water level is 28 inches. Then at t equals 1, it's going to be 4.5 times 1 plus 28, which is 32.5. So at t equals 1, it went up by 4.5 inches. Then f of 2 is 4.5 times 2 plus 28, which is 37. Yeah, which means at t equals 2, it went up again by 4.5. So that's what is going on here. When it says sketch a graph, you're basically drawing the function. At 0 it is 28 and then it increases. So this is t and this is f of t. Okay, so it's going to be a straight line because it's a linear function. The slope is exactly 4.5, which gives you, from our previous discussion, the rate of change of water level. And you can already see that going from 28 to 32.5 is a plus 4.5. Going from 32.5 to 37 is another plus 4.5. So each time the water level is increasing by 4.5, and that is because it is precisely the slope. Now in this particular example, the model was already given to you and you were just trying to analyze what's going on. In the next example, we are going to build the model from the given situation. So here's a problem from the textbook. It says water is being pumped into a swimming pool at the rate of 5 gallons per minute. Initially, the pool contains 200 gallons of water. Find the function v that models the volume of water in the pool at any time t. So say we have a swimming pool, and initially, so at t equals 0, there's already some water in it. How much? 200 gallon. So we need a function. Let's say this function is linear and it's given by okay, let's stick with maybe mx plus c because we're more comfortable with that. And we know that at x equals 0, y is 200 gallons. So plugging that in gives me, y is 200 here, is m times 0 plus c, therefore c is 200. So I have that part down. Now it says that the rate is 5 gallons per minute. Now let's say x is measured in minutes. This rate is precisely the slope, which means that is m. So m is 5, which gives me the model to be 5x plus 200. That's how many gallons after x minutes. Okay, so we have a linear function that models. Now it says if the pool has a capacity of 600 gallon, how long does it take to fill the pool? So that means we're trying to solve for what value of x is this equal to 600. That's the 600 gallon is how much water is required to fill the pool. And then we're just trying to find that what value of x gives us that. So solving that gives me 5x equals 400 and x equals 80. This 80, remember, is in minutes. So it takes 1 hour 20 minutes in order to completely fill the swimming pool. Okay, let's look at another example. In this figure, there is a staircase in a coordinate plane, and the origin is at the bottom left corner. The red line is the edge of the trim board of the staircase. And they're asking us to find a linear function h that models the height of the trim board above the floor. So this one is kind of easy here. There are multiple ways of doing this. First of all, we notice that hx, whatever that function is linear. So one way to do that is to first find the slope, which we can do because we have 2 points, right? So it's going to be change in y, 32 minus 16, over change in x, 36 minus 12. So that is change in y and change in x. This comes out to 16 over 24, which is 2/3. And then finding the equation amounts to picking one of the points. So y minus y1 is m times x minus x1. This is called the slope point form for a line, which says that if I have a point x1, y1 and a slope m, then the equation of the line is exactly that. So that's one way to get it. The second way to get this is, as the book suggests here, start by making this assumption that hx is linear ax plus b, and then it should satisfy those points 12, 16 and 36, 32. So 12, 16 means this is 16 when x is 12, and this is 36 when x is 32. And at this point, this becomes a system of two equations that you can solve by subtracting. This gives you negative 20 is negative 20a, and you get a is 1. So let's see, did I make a mistake here? 16, 12, b. Yep, this should be 32 and this should be 36. This is 32, this is 36. That's because the slopes should match up. It's the same problem. So this gives me negative 16 and this gives me negative 24a. So a is 2/3 like we have from up there. And then once you have a, you plug in a and you solve for b, because your eventual goal is to find a and b to get the ax plus b form. Second part says, if the space available to build a staircase is 11 feet wide, how high does the staircase reach? So if it's 11 feet wide, right? So what this is giving me, what is this 11 feet? This 11 feet is actually the change in x, right? Because that's the width. So now the problem is asking me, if I only have 11 feet, how high can this be given that my slope is 2/3? Now slope is change in x over change in y, or rise over change in y over change in x, rise over run. So we're given that the run is 11, then the rise is m times the run, which means it is 2/3 times 11. So it's 22 over 3 feet, which means that in the given configuration, if the width is limited to 11 feet, then the height can only reach 7.66. 7.33. In the next video, which will be the last for this topic, we're going to look at a model that involves speed and also involves two different models, and so it's going to bring in the idea of solving a system of linear equation and getting information from it. That's it for this video.